SOA, SOHCAH, to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Sometimes I teach my kids some old hippie called a high tripping on acid, same letters there. That's one. Somehow my husband's favorite one, and we had the same geometry teacher, so I don't even know where he got this from because she did not say this, is Oscar has a hairy old arm, or whatever other a body part of choice that you want to fill in the blank with there. But anyway, those are just like little things to help you remember. Yeah. So these are all just things to help you remember about sine and cosine. So let's do a little bit of review here. So I have just a basic trig problem, and the question is asking me to find the length of AB. So that's this side right here. Oops, got the giant marker there. So I'm going to call that X right here. So this angle is the one that I know. Okay? When I look at that triangle right there, Wade, which side is my hypotenuse?
The hypotenuse would be
Nope.
no, the right. Yeah.
It's side AC, the one that has a length of 10. This is your hypotenuse. You may have been looking at the wrong triangle there. So that is our hypotenuse for this triangle. And then I need to know what this side is, because that's the side I'm trying to find. So would it be the opposite side or the adjacent side? Opposite. It is across from the angle that we know. Okay? The hypotenuse and the adjacent actually touch that angle. So like I already know this one's my hypotenuse, so the other part right there would have to be adjacent. But we don't really need that for this problem because it doesn't ask us about adjacent and doesn't give us adjacent. So if I want to set up this problem, I've got opposite and hypotenuse, so I need to use sine. So I would say sine of 35 degrees is opposite, which is x, over hypotenuse, which is 10. Okay? And then I want to solve that equation for x, so what do I need to do? Multiply both sides by 10. I'll get rid of the 10 over here, and I'll have a 10 over here. And I can type that into my calculator. Now, there is something that you need to check on these calculators, and they probably have been reset since they were last used for trig. So, everybody get your yellow calculator. Even if you don't usually follow along, get your yellow calculator because you'll get these wrong if you don't have this. So, hit the mode button. The default for these calculators, if they have been reset, is for them to be in radian mode.
Degree.
We need degree because this problem has degrees. So you're going to go down to that third line, go over to where it says degree, and hit enter on your calculator. So make sure you put your calculator in degree mode for me. So hit mode, which is right beside of that blue button. Then go down to the third line, over to degree, hit enter. Okay. There might be some of them that were already on degree, but if they have been reset recently, they're on radians. Okay? Alright, so we're going to now type in 10. 10 sine 35. And we'll get 5.736 if we run that to 3 places. So 5.736 is our x. sine of 35. All right. Okay. So, let's have you guys try now I've got one or two more on this next one. A couple more. I want you guys to try those on your own. Try to reach back into your mind and remember how to do this regular trig. Okay? I'll freeze my screen here.
Wait, can you go to the screen before?
Yep. Oh well. Maybe. I got rid of the writing. Let's see if it'll come back. Just freeze it there. Okay, so try example 3 and example 4. Oh, I'm sorry. Example 2 and example 3.
How many decimals we got?
Do 3.
She said, or wait, who was it? Chrissy David, she said, what do you guys do? And then you went, no, really? Oh, you were there.
All right. Try these problems.
Got my 8.918.
12 over x. No, so what you're going to have to do is multiply both sides by x, and then you have, like that cosine 42 is just a number, so you're going to divide both sides by cosine 42, so you'll be doing like 12 divided by cosine 42. Yeah. Round your final answer to 3 decimal places.
To the up. You doing the right thing? Yeah, I'm doing the right thing.
I'm not done yet, so.
Oh, I just gave you the answer, my fault.
You're not got the first one right. All right. I'm gonna walk around and see what our answers look like for this.
I think I got it. I'm super positive. Okay, why are you looking at me like that? I think I got it. So that's
Okay, so you do this number on the outside first?
one.
Okay.
That one, the degree always.
Even though there is a chance, that is a
What?
a European crop.
Is it 2,000? Wait, is it?
Several countries use the decimal like we use the comma and use the comma like we use the decimal.
So it's not.
Like, but Paloma, you guys know Paloma, it's from Argentina. She uses, so she wants to write 0.75. She writes like this.
So is that
If
1,000?
she wants to write 3,400, she writes it like this. Argentina obviously is a country that does this. There's lots of countries that do it. Most of I had not seen it until I was watching some videos in Spanish for some. I was trying to find some for some of my students that did not speak English very well one year, and they were from Spain, and they did that. But most of like the U.S. obviously uses like we do. Canada does. Most of your like Mexico, Central American countries also do like we do. But Argentina, obviously, or at least Paloma. So I'm assuming the rest of Argentina with her. So there's a chance it was supposed to, like it is like a comma, but so yeah, but I didn't like 2.5.
Oh, I did
But
1,000.
if you're in a different country, maybe it is kilometers too, which would be pretty much the rest of the world uses kilometers. Okay. All right. Here's what you should have. Most of us did not solve the first one right. Oops. I think the only ones I saw which is correct were these two over here. So this one is a little bit. All right, everybody, look. You need to use cosine for this. This is adjacent and hypotenuse, and this one's a little tougher because when you set it up, let me rewrite where I set it up. You're going to have cosine of 42 equals 12 over x. So your x is in the bottom of the fraction here. So you cannot just do 12 times cosine 42 like we did on the other problem because you're not dividing by 12 right here. So what you have to do when this happens, whenever you have that x in the bottom, is you want to multiply both sides by x. That will give you x cosine 42 equals 12. And then cosine 42 is just a decimal. Like if you type it in, cosine 42, you got 0.74314. So you're just dividing both sides by cosine 42. So you could do 12 divided by that decimal. Or you could write it as 12 divided by cosine 42. That's the way that I did it. And it gives you the answer for that. I did see the correct answer for several of you guys on number 3. That one, you should set it up.
Do we have to put a 0 to 46 on the answer?
No. Oh, shoot. All right. So, we would have sine of 15.7 would equal h over 2.5 right there. We were discussing the possibility that this could be like I just pulled it from the internet. It could just be a European problem where that was meant to be 2,500. It would kind of make sense because they put the zeros on the end. But
They don't use periods or something. This is probably saying that.
yeah, in some countries, like I know in Spain, most Spanish-speaking countries, like Central America, are going to do it like we do. But definitely Argentina, because Loma does this and she has missed some problems because of it, because she put in like a comma when she should have done a decimal or something. So if I have 2.75, Paloma would write it as 2.75. They use a comma instead of decimal point. And then like we would write 3,421.8. Loma would write Really? Yeah. Yeah. Yeah, Greece. There's a lot of European countries that do it that way. So interesting to know. I did not learn this till a few years ago, and I felt like that should have been something they taught me in school. How did I not know that? Until I had been a math teacher for 10 years. Well, it's not just Americans on this, because now, when we're talking units, pretty much the rest of the world uses meters. They use metric systems, right? We're about the only holdouts. But this is more split. It's like there are lots of countries that do it like we do, but there are also lots of countries that do it this way too. So it's not just us on this one.
Do you think we're going to change and be like everybody else?
This I definitely don't see this changing, because there are lots of other countries that do it this way. But metric.
Why don't we change it already?
Not that I want to. I don't want to. Yeah.
America.
Yep.
Yeah. Metric is much easier, but it causes you have to change your whole mindset on things. It's easier to calculate with, but somebody tells us it's 25 degrees Celsius outside. We don't know what that means.
What is that? Is that cold or hot?
Medium.
I think it's kind of medium.
Because I remember that woman.
All right.
That woman last year came from the UK, and she was like freaking out because she was reading the letter from the girl. She was like, "What's this?" And that was my
Yeah. Okay.
What's the bloody?
All right. Okay. Now we had to go over that stuff that we were just doing. Guys, quiet. 0.6. All right. So the stuff that we were just doing, we need to review so that we can now take what we know about triangles and connect it to the unit circle. Okay. So we are going to we have here a circle graph that has its center at 0, 0 and has a radius of 1. So you can see this circle right here. The circle right here has a center at 0, 0, and it has a radius of 1 unit. Right? So like I could go up, down, left, right, 1 unit, and that'll be on the equation. So what is the equation of this circle? This is a review question. We did equations of circles. So it was like, it had like an x squared and a y squared.
Like x squared plus.
It's 1 squared, but 1 squared is still 1. So you'll see this written probably like this: x squared plus y squared equals 1. So I just threw that in as a review because it is something that we also have to cover in this class. So I just typed this into Desmos. It graphed me this. I posted it on this slide right here. So we are going to take this circle right here, and we're going to put some triangles on the circle. All right. So what I have done, I'm just looking at like this first quadrant, so I sort of zoomed in here. And I drew me a triangle here that has this angle right here is 30 degrees. Okay. So this 0.5 right here is not labeling that side as 0.5. This right here, that right there is 0.5. This right here kind of fell behind the circle. That's a 1 right there. So that is not saying that the length of that side is 0.5. It is saying that tick mark right there is 0.5. Guys, quiet. All right. So we're going to draw a circle like this, and we want to know what would the coordinates of this blue point on the circle be. So, if I have the point x, y, right, that would mean my x-coordinate, which would be right here, would be x units over, right? So that would be the length of this side right here. So I could label this side right here of that triangle x. And then the y is my y-coordinate, which means right here, it looks like it's about 1/2, but I can't know for sure that it's 1/2 yet. So this side right here, I'm going to label that y. Those are going to be our x and our y coordinates. That length that we go over is my x coordinate. The length that I go up is my y coordinate. So let's pull this off of the picture now. So what I've got here is I've got an x right here, I've got a y right here, I've got that this is 30 degrees. What is the length of this hypotenuse right here? No, it's not x. This is our center, right? This is a point on the circle. So that means, what could we call that side? It's a radius, and this circle has a radius of 1. All the radii are going to be the same, right? So the length of this side right here is 1. This is going to be called the unit circle because the radius of the circle is 1 unit. Okay? So I can use trig to find x and to find y here. So if I want to find x, 30 degrees is my angle right here. So this would be my adjacent side. This would be my opposite side. And this would be the hypotenuse here. And so I will, if I want to find x, let's look at x first. We got to do x and y separately. If I have adjacent and hypotenuse, that means I need to do cosine. So I would do cosine of 30 degrees equals adjacent, which is x, over hypotenuse, which is 1. I could multiply both sides by 1. It really doesn't change anything. I'm going to get cosine of 30 degrees equals x. And if I type that into my calculator, cosine of 30 degrees is going to give me 0.866. Now, there is something special about that that I need to let you guys know. That decimal does not immediately look like something that you should recognize because we're getting like 0.866 and so on. But in exact form, and I know this, there's no reason that you wouldn't, I'm not going to spend the time explaining it, that is square root of 3 over 2. And we have to know that right there. So if I do square root of 3 divided by 2, I'll get that same decimal. The answer to the y question takes too long for me to answer, so I'm not going to do that right now. It does. It does. Let me tell you, we have to do it this way. It's what the answers are going to look like. And the answer to y is too long for me to go into. So if you want to come to Smart Breakfast and ask me why, I will gladly tell you. There's reasons, but we don't have time to talk about why right now. All right, so we got to find y real quick. That's just our x. So for y, that's opposite and hypotenuse. So we'll do sine of 30 degrees is going to equal y over 1, which means we're just doing sine of 30 degrees, which is friendlier than cosine. Sine of 30 degrees is going to give you 0.5. So, all right, so y is going to equal 0.5, or we're going to use fractions for this. This fraction hopefully will not upset you as much as the first fraction did. We're going to use a 1/2 for that. So The coordinates of this point right here are square root of 3 over 2 and 1/2. Okay? We will finish these notes tomorrow. You do not have any homework tonight, so enjoy your break there.